What is hashing? When you think of hashing, it's literally taking a piece of data, big or small, run it through a function and output a fixed size string of bits. This output is called a hash or a message digest. Here's an example using a hashing algorithm called SHA-256. The output for this algorithm is always 64 characters long. No matter how short or how long the input is, SHA-256 output is always 64 hexadecimal, which is 256 bits. Got it? Good. Now I need you to understand that a good hashing algorithm is one way. Now you can create the hash from the data, but you can't recreate the original data from the hash. Also, two pieces of data should not produce the same hash. Otherwise, it's called a collision, and the hash is insecure. So how does hash prove integrity? Well, hashing is used to protect the integrity of our data. Let's say Lucy and Ricky are working together. Lucy stores the hash of Ricky's password, not the password itself, the hash value. When Ricky logs in, he types in his password. His computer hashes it and sends the digest to Lucy. Lucy then compares it to the stored digest. If they match, she knows Ricky typed the right password. With hash, there's no need to ever store or send actual password. Hashing also protects file integrity. Here's a scenario. Let's bring Lucy and Ricky back. Let's say Lucy's a software developer and many people around the world purchase it for use. The problem is there's a lot of fake software version out on the web, and hackers are trying to trick people to download theirs rather than a trusted original that Lucy created. Well, Lucy can simply publish a hash value of her software on her website. So when Ricky buys the software from a third-party vendor, he can compute the hash on his own for that software. If Ricky's hash matches the one that Lucy posted, he knows the file wasn't tampered with. If it's different, then Ricky knows something's wrong, like maybe a hacker slipped a malicious file altering the original file. Hashing is a quick way to verify things have not changed. Here's some popular hashing algorithms. You have SHA, which stands for Secure Hash Algorithm. These are strong and secure. The most popular version is SHA-256. It produces a 256-bit digest. And then you have MD5, Message Digest Algorithm number 5. This one produces a 128-bit digest. It's much faster, but considered weak today. But it's still being used today for compatibility reasons. For the exam, remember SHA is the go-to for serious security. Now, encryption doesn't just protect secret. It also proves identity and integrity. A digital signature is created by combining symmetric encryption and hashing. Let me give you an example of how it works. Lucy again. Lucy writes a message. She runs it through a hash function like SHA-256 to create a digest. She then encrypts the digest with her private key. This ciphertext becomes the digital signature. Lucy then sends Ricky a copy of the message. Once Ricky receives it, he uses Lucy's public key to decrypt the signature and recover the original hash, because the signature was decrypted using Lucy's public key. It means it must belong to Lucy because the only thing that must have encrypted it was the matching private key, which only Lucy has ownership of. Ricky hashes the received message himself and compares the two hashes. If they match, Ricky knows the message wasn't changed. That's integrity. Ricky knows it's only from Alice. That's authentication. If they don't match, either the message was tampered with or someone else tried to fake it. Let's talk about some algorithms that are common for digital signature. You have PKCS number 1. This uses RSA for digital signature. Then you have digital signature algorithm, DSA. This is older, but is still recognized today. Then you have your elliptic curve DSA, ECDSA. It's newer, faster, and uses smaller keys. It was developed under the US government's FIPS standards. Today, ECDSA is becoming the most popular for secure digital sign-in. Alright, here's a recap. In this video, you learned hashing creates a one-way fingerprint of data. Hashing is used to verify password and file integrity. You learned about digital signature and how it combines hashing and asymmetric encryption to prove both identity and integrity. You learned that SHA-256 is the strongest widely used hashing algorithm. And lastly, we learned ECDSA is the leading choice for creating fast, secure digital signatures. See you in the next one.